right, welcome to video number 2. Okay, if you watched video number 1, I talked about the charges when an atom becomes an ion. And then also I talked about the number of valence electrons that an atom has, which you can determine by looking at its location on the periodic table. So in this video, we're going to look at the Bohr model of the atom, which I'm about to show you, and we're going to show how understanding the Bohr model of the atom will explain how the number of valence electrons relates to the charges that it becomes when it has an ion, and how we can demonstrate that by using the Bohr model. Okay, so let's look at this. All right, so here I have a Bohr model, and remember, the Bohr model is not exactly the most modern, but it's the one that we use because if I tell you, so an electron is in an undefined area, undefined space. I can't physically draw that for you. It's too abstract. So when we're drawing, when we're trying to show examples of where things are, where electrons, rather, not things, but where electrons are, we use the Bohr model. Okay, so I have some beads here that I'm going to be playing with. If you just saw me bring in some paper plates, I've got beads. I'm not eating lunch or anything fun. I have some beads I'm going to be using to help me explain this. So I'm going to start with nitrogen. And nitrogen, if we look on our periodic table, has 7 electrons total. Okay, we see it has 7 total electrons, 5 valence electrons, but it has 7 total, 7 total electrons because it's an atom. But that 7, of course, we know represents the number of protons that it has. But because I've told you this is an atom right now, it also represents the number of electrons that nitrogen has in its ground state of an atom. Okay, so I'm going to put these 7 protons in the nucleus. You see that center circle said nucleus, so I'm going to put those in there. Okay, so my protons are represented by those red beads. Well, I always refer to neutrons as being the peacemakers of the nucleus because, you know, like charges repel, and if we have a whole bunch of like charges in here, they're going to just push each other all over the place, and the neutrons kind of keep the peace. So they keep these protons from destroying one another, okay? So I put 2, 4, 6, 7 neutrons in there, and I always think of blue as being a calming color, so that's why I chose blue as being the color for my neutrons, okay? Because like I said, they are the peacemakers of the group. Okay, now I have selected some, these are called snake eye beads, and I am going to get out 7 of them. 2, 4, 6, 7. Okay, and I'm going to take my snake eye beads, and that first energy level, don't forget, that first energy level, if you watched video 1, and if you remember from our previous discussions in the last week or so, that first energy level can only hold a maximum of 2 electrons. Okay, so I'm going to put 2 electrons there. Well, you see here that I have kind of over here, I'll put them over here so you can see them. I have 5 more electrons that I need to place, okay? So I'm going to put all 5 of these in this second energy level, and you see here it says second energy level, right? So I've labeled that. So in this second energy level, actually I'm going to put different color snake eyes for my first energy level so you can see the difference. Okay, there we go. So I have these two blues are my electrons for my first energy level, and then my second energy level, those are represented by the yellow snake eyes. Okay, so now remember in our last video we talked about the fact that all atoms want 8 valence electrons, and our valence electrons are those electrons that are in the outermost energy level. Okay, when nitrogen is in its ground state, there are no electrons in the third energy level. Okay, there are none. So nitrogen wants 8 electrons in its outermost energy level, which is this second energy level. So nitrogen is going to, what I call, beg, borrow, or steal electrons from another atom, maybe that has extra, or another atoms that will form a bond with nitrogen, and we will talk about that more in detail, bonding that is, when we get to chapters 7 and 8. But for now, we know that they want 8 valence electrons, so I'm going to put 3 more because I have 5. So I'm going to put 3 more, and I use this bright orange to represent the electrons that nitrogen stole or borrowed, or however you want to refer to that, from another atom. Okay, so now I have 8 electrons in this outer shell, right? So I have 1, 2, 3, 4, 5 that I originally had, and then I have 1, 2, 3 that nitrogen got from another atom. Okay, so there are 3 extras, 8 total. Now let's look at the charge that this nitrogen ion, because now it's an ion, right? So because an ion, don't forget, is an atom that has lost or gained an electron or electrons. Okay, so nitrogen has gained 3 electrons. So let's count our positive charges. Remember, our protons are positive, so we have 1, 2, 3, 4, 5, 6, 7. So we have 7 positive charges. Okay, 7 positive charges. Now let's count our total negative charges, which are our electrons, right? So I have 2 in this first energy level, and I'm going to start over here. So I have 3, 4, 5, 6, 7, 8, 9, 10 total electrons in this ion. So if I have 7 positive charges and 10 negative charges, so that kind of looks like this. If I have 7 positive and 10 negative, okay, so if I have 7 positive and 10 negative, I end up with a 3 negative charge, right? So if I have 7 positive charges, 10 negative charges, so 7 minus 10 is 3 negative, okay, or negative 3, okay? Now, if you look at this, nitrogen is in this group right here, in group 5A, and look at that, 3 negative. Huh, well, isn't that pretty cool? And I've totally messed up all these valence electrons, but all right, everybody good there? Fabulous. Now we're going to do one a little bit different. I'm going to take away my electrons. I'm going to leave my protons there because I'm just going to be adding some to it. So I'll leave those there. I'm going to go over here and I'm going to do magnesium. Okay, magnesium's right here. Magnesium has 12 protons, and because it's an atom, excuse me, goodness, because it's an atom, it also has 12 electrons. So I'm going to get out, I already have 7 protons, so I'm going to get out 5 more. 8, 9, 10, 11, 12. Okay. And the most common isotope for magnesium is magnesium 24. So I'm going to get out 5 more neutrons, and I'm going to put those guys in here. Okay. If you'd like to stop the video and double check my counting, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 reds, so those are my protons. So I have 12 protons, and then I have 2, 4, 6, 8, 10, 12. Neutrons are represented by my blues, so I have 12 neutrons there as well. Now I'm going to do the same thing I did last time, and I'm going to get out 12 electrons, okay, because in this atom I have 12 protons and I have 12 electrons, because we are dealing with an atom here. Okay, this atom, or that electron's not sitting well, it's not flat on one side, so I'm going to get a different one. 2, 4, 6, 8. Okay, and let's see, can you see those? Yes. So I have 2, 4, 6, 8, 10, 12. Perfect. Okay. Actually, I think you'll be able to see these better than those whites, so I'm going to take those away. All right. So now I'm going to start placing my electrons. I have 12 electrons here that I'm going to place, okay? So I'm going to take my blue ones just like I did the first time, and I'm going to put those in the first energy level. Don't forget, the first energy level can only hold 2 electrons, right? Because it only has, remember in our last video, we only have an S sublevel, an S sublevel in that first energy level, as shown on our periodic table. I have so many periodic tables here that there we go. On our first energy level, I only have an S, okay? Then on the second one, I have a 2S that can hold 2, and I have a 2P that can hold 6. So that second energy level can hold a maximum of 8 electrons. So I'm going to take 8 electrons, and I'm going to put them in this second energy level. Okay, there we go. There's 8 electrons in the second energy level. So here I have, don't forget, I'm dealing with magnesium now, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have 2 more electrons to place here. So I'm going to place those in this third energy level, okay? How many valence electrons do you see on my Bohr model? That's what this is called, my Bohr model. How many valence electrons do you see on that Bohr model? Well, I see 2, right? I see 1 right here and 1 right there. Don't forget, your valence electrons are those outermost electrons. Well, let's look here. Magnesium's right here in group 2A, and up here it says we have 2 valence electrons. Huh, that's pretty cool. All right. Now, remember how I said all atoms want how many electrons in their valence or their outermost shell? They want 8, right? Okay, what do you think the chances are of magnesium getting 6 additional electrons? Pretty slim, I would think. But if magnesium can give away and form a bond with another atom and give away these 2 electrons, look at what happens. So if it loses these 2 electrons to another atom and they form a bond, this outer shell is empty. Now its valence or outermost shell is this second energy level. And look, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are in that outermost or valence shell. Oh my goodness gracious, isn't that cool? Well, let's look. If we have, I'm going to kind of scoot in here a little bit. If we have magnesium, right, we had 12 positive charges, okay, and I now have 10 negative charges, right, because I have 10 electrons. This results in a 2 plus overall net charge, right? Well, look at this. Magnesium's right here in group 2A, and look at that, 2 plus charge. Now do you understand how this all kind of works and links and like connects and makes sense, right? Oh my goodness gracious. How cool is that, right? Okay, let's do one more. Let's do it doesn't really matter. Do we want to gain or lose is the question. So let's do oxygen. Oxygen has 8 excuse me, it has 8 protons, so I'm going to take away 4 of these. Its atomic number is 8, which means it has 8 protons, and it has 8 electrons. So I'm going to put 8 electrons here. 2, 4, 6, 8. Okay, so there's my electrons that I'm going to place in just a moment. Okay, I gotta find my paper plate. My paper plate's what I hold all my all my beads on right now. Okay, so then, okay, now I need to get rid of some of these neutrons too. I'm going to take away some of those. So oxygen 16 is our most common isotope. So I should have, remember that 16, when we write like oxygen, that 16 refers to the, anybody remember? This is the mass number, which the mass number is equal to the number of protons and or plus, okay, I'm going to write plus, but I didn't want to write the symbol plus because I had a plus sign there. But I'm going to write plus the number of neutrons. Okay, so the mass number, that oxygen 16, that number 16 refers to the mass number, and the mass number is the number of protons plus the number of neutrons. Okay, so I just told you that oxygen 16 is the most common, and here I've got 1, 2, 3, 4, 5, 6, 7, 8 red ones. Those red ones represent my protons, and then I've got 8 neutrons. Those neutrons are represented by my blue. Remember, they're the peacemakers. I'm just kind of just playing with these and moving them in there to kind of separate the protons how I can imagine that they might actually be. Okay, they just kind of keep the peace in there, and they just keep those protons from throwing each other out. Okay, so let's put 2 of our electrons in that first energy level, because of course we know by now that that first energy level can only hold 2 electrons. Then we're going to place these extra 6, not extra, these the next 6 electrons in the second energy level. Okay, So I have 6 of them there. 2, 4, 6. Okay. So I have 6 of them there. So I have 6 valence electrons. How many does it want? It wants 8. So I need 2 more. So I'm going to grab